In this problem, for part A, it's saying, if you read the problem, it says a mass of 4 kilograms is hung on a spring so that the mass hangs at rest. If it hangs at rest, then that means it's not moving up or down. There's no force on it, and that means that my forces that are on it have to be balanced. Well, if you look at the picture, the only forces that are going to be on this when it hangs at rest, you're going to have the weight in one direction, and that's going to be opposed by the spring force in the other direction. So this is your spring force, and that's your weight, and those two have to be equal. Now our formula for the spring force is Hooke's law. We have that the spring force equals minus kx. Well, the thing about this is the minus just tells me the direction. It means that since I'm actually stretching this from its position where if there was no weight on it, it would be up here, so it's stretched in that direction, the spring force is always in a direction opposite to its displacement. So since its displacement is down from where it would be without the mass on it, then the spring force is up. So I don't have to put the negative when I actually write this in, but that force has to equal that. So I can say that kx is going to equal the same thing as W is mg. So there's my formula, kx equals mg. And now, and I know the k. Okay, the k was given in the problem. The mass was given in the problem, and g is a known. So we're looking for how much is the spring stretch. So all I have to do is rearrange this equation to solve for x. It's just mg over k. So if you put in the numbers, you're going to have 4 kilograms. For g, well, you can put 9.8 or 10. I don't care which one. I mean, either one, I gave it to you. And then for the k, 50 newtons per meter. So solving that came out to be 0.78 meters. All right, any questions on that? So that's all the work you had to do for that, was just say Hooke's law equals the weight equals the spring force, and solve it. Yes? What's that? Because the k, the negative, just tells me the direction. Like what the negative means is the spring force is always in a direction opposite to the direction it is displaced. So if there was no weight on it, the spring would be up here. We put the weight on it, it's going to hang because of the weight. And now they're going to be balanced. So notice the displacement was down from where it would have been if there was no weight on it. So the spring force is up. So that's what the negative means. So I didn't have to bother putting it there because I took care of the direction when I said that those two were equal. Because in reality, the equation would be, if I called down my positive direction, it would be mg minus kx equals 0. It still means mg equals kx. All right? You can use either one. All right, and I'll do both of these at the same time because this one doesn't take a lot of... Now this one, you just have to figure the right equation. So in this particular problem, I know on one version of the test, I think in the other version of the test, the unknown was what's the angular frequency. So in the A version, you would use the formula omega equals the square root of k over m. That's what you would have used if the angular frequency was the unknown, which may be the question in the part C version of this test. Okay, because it could be the angular frequency. But in this one, the question was, what is the period? Well, the formula for the period is 2 pi square root of m over k. And I have m and I have k. I have both of those numbers. So it's just plug into that formula. So 2 pi square root, the m in the problem was 4 kilograms. And the k in the problem was 50 newtons per meter. And so you're just literally plugging it into the formula. You don't even have to rearrange it. The answer came out to 1.78, and period is measured in seconds. So if we actually did our, a kilogram and replaced that with kilogram meters per second squared and did all the cancellation, we would get seconds for our unit. Yes. I suppose I could ask you what the frequency is. If the frequency would be 1 over t. So whatever the answer is right here, 1 over 1.78 would be the frequency, which would be in hertz. So notice that the angular frequency, that's in radians per second. The period is in seconds, and the frequency is in seconds to the -1, or hertz. Yes?
What's the difference between frequency and angular frequency?
Frequency is how many times something happens in a given amount of time. So it's the number of cycles per second. So there's no unit for the number of cycles. So that's why your unit for frequency is seconds to the -1. Angular frequency is pretty much, it's sort of like a velocity that it's moving at, but it's based on the fact that a full cycle is going through what we call 2 pi radians, is what we consider a full cycle. Even though, like, a pendulum doesn't necessarily have to be moving through 360 degrees, it means that there are certain points. There's when it's at its maximum amplitude, its equilibrium position, where we can call it the 0 degree point, the 90 degree point, the 180 to 270, right? Whoops. That's still going.